In example 3.3, we're going to have a little bit more of a closer look at what this limit word actually means mathematically. So if we're trying to calculate the limit as x approaches -2 of x plus 2 on x squared minus 4, really what we're wanting to find is what is the function doing at x equals -2. Does the function have a value at that point, or is the function undefined at that point? So just like we would do if we were trying to find the value of the function, we can substitute our x equals -2 into the function itself, which is what we've done here. The problem with doing that directly, though, is we end up with this situation where we've got 0 divided by 0. It's okay that the numerator equals 0, but the denominator causes the function to be undefined at that point. And so we can't just let that sit. We can't just go, oh, well, we'll just say that it's undefined, because it's not necessarily true that it's undefined at that point. So what we're having a look at is we've got to factorize first. Okay, it's super important that you factorize and simplify the function as much as you possibly can before you substitute in the value of interest. So again, using difference of two squares expansion in the denominator this time, x plus 2 on x squared minus 4 becomes x plus 2 on x plus 2 x minus 2, and we can cancel these factors of x plus 2, which leaves us with this bit here, limit as x approaches -2 of 1 on x minus 2. Notice that the limit as x approaches -2 is still being written. Okay, you must write it on every single line until a particular point. And that particular point is when your function is as completely simplified as possible. There's nothing further you can do to simplify it. There's nothing that can be cancelled, nothing that can be factorized. Once you have reached that point, and only once you've reached that point, you treat this limit as x approaches -2 as an instruction. And the instruction is, once the function is simplified, sub in the value of x that's given. All right, so the instruction, I'll write that down. Once the function is fully simplified, sub in x equals -2. So that's what the limit statement is telling us to do. And until you've simplified it, you must keep writing down the limit. If you forget to write it on your line of working, you lose marks for it because it's extremely important. All right, so we've got 1 on x minus 2. That's our most simple version of this equation. And so we sub in x equals -2, and we simply get x equals, the limit is -1 on 4. So what that means is, as the function, and you can graph it, as this function approaches, x value approaches -2, the y value is going to approach -1 on 4. You should recognize, however, that the function is actually discontinuous at x equals -2, because -2 squared is 4 minus 4 is 0. So we would have an asymptote at this point because it's a rational function.